Dr. Gary Glassmeyer 喺1971年從美國密爾沃基馬凱特大學嘅物理同埋數學系理學士畢業，並得到優等生，及後喺1980年得到美國科羅拉多大學嘅物理學博士學位。喺1998年開始 ，Dr. Gary Glassmeyer 喺美國加州大學聖克魯茲分校擔任地球學同埋行星科學系嘅教授。喺1990年代 ，Dr. Gary Glassmeyer 曾經用上4年嘅時間，利用所有有關地球磁場嘅資料，再利用超級電腦嘅協助底下，對地球嘅磁場作出圖像模擬分析，意外咁發現地球磁場出現倒置時嘅先兆，就係每當地球嘅磁場減弱，地磁嘅南北極就會唔穩定，南極同埋北極會散開並流動，導致多個南極同埋北極出現。北半球會開始出現一部分嘅南極，而相反，南半球會出現一部分嘅北極。
Scientists needed to discover whether there was a link between changes in the strength of the magnetic field and changes in its direction.
It was a very intriguing problem, something that was screaming out for an answer, and computers were becoming powerful enough to actually solve a full set of equations that describe convection in the core of the Earth and how that motion generates a magnetic field.
In the 1990s, physicist Gary Glassmeyer decided to embark on a very ambitious experiment. He put all the essential facts that scientists had learned about the Earth's molten core into a computer model, dozens of equations describing its dimensions, temperature, viscosity, and so forth. Then he let the model run to see how the magnetic field would evolve over hundreds of thousands of years of simulated time.
It's important to understand just how long these simulations take. Each time the computer solves the equations, it advances the whole solution one time step, and the time step is typically 10 days. And within 10 days, things don't change much, which means you have to do many solutions. You have to solve it millions of times, tens of millions of times, in order to be able to simulate hundreds of thousands of years, which is what we needed. One case may take 6 months of running on the fastest computers in the world. I was using supercomputers from the Department of Energy, from NASA, and the National Science Foundation, and no matter where I was, the first thing I do is make sure the computers didn't crash. So it was something I did every day, 7 days a week, for over 4 years. And I remember there was a period of time, I believe it was in the fall, and I was traveling to other universities and giving talks, and after a number of weeks I came back and decided, well, now I need to look at the details of the magnetic field, and realized that it was in the reverse polarity. It already had reverse. This is something I didn't expect. So then I looked at many snapshots during the time I was gone and realized that the field did indeed reverse spontaneously. This is the first time it happened. We were very anxious to write about it. It was really exciting.
And as the experiment continued, so did the reversals, every 100,000 years or so of simulated time. And crucially, each time the field reversed, the process began the same way.
What's interesting is whenever it has reversed its polarity, its direction, that happened when the magnetic intensity was very weak. So it was decreasing. Finally, when it was the dipole part of the field was very weak, then the field reversed.
Here was the evidence that what we are seeing today, a loss of field strength, is indeed linked to the onset of reversals. What's more, Gary could see why reversals are heralded by a weakening field.
Now this movie will show part of a simulation that spans magnetic field reversal. What you see here, blue represents inward-directed magnetic field, the gold represents outward-directed magnetic field.
In Gary's model, reversals seem to start with the appearance of islands of blue in the gold, and vice versa. These are magnetic anomalies, regions of the core where the field is already flowing the wrong way. As they grow, these patches where the field is reversed start to cancel out the main field, making it weaker and more liable to flip.
You see, as the time goes on, the field becomes more and more complicated, and then you get an anomaly growing in the northern hemisphere where magnetic field now is going out. There's a reversal. Now the magnetic field is outward in the northern hemisphere and inward in the southern hemisphere.
So now the burning question is what's happening in Gary's model reflected in the real Earth? Is the 300-year decline in our field, which the pottery reveals, the work of magnetic anomalies brewing deep in the core beneath our feet? If so, then a reversal really could be in the cards. Amazingly, there are detailed records that cover exactly this 300-year period. The logbooks of Her Majesty's Navy. For as geophysicist Jeremy Bloxham has discovered, 18th and 19th century sailors were obsessed with the magnetic field.
Back in the days of James Cook, when he was doing his voyages of exploration, a compass was the primary means of navigation. However, a compass needle doesn't point at true north, at the real geographical North Pole. Instead, it points at magnetic north.
For sailors, knowing the difference between true north and magnetic north was a matter of life and death. But as they were well aware, magnetic north keeps moving, wandering about near the pole as the field gradually changes. So navigators needed to measure the difference between magnetic north and true north, the angle of variation. They did this by comparing their compass bearing to an astronomical calculation of true north.
The trick was to find true north, and they could do this by looking at the sun at noon when it's highest in the sky, alternatively by looking at the angle the sun made at sunrise or sunset. Here on the 8th of June 1770 we have a magnetic variation of 4 degrees and 53 minutes east.
Thousands of these observations, together with early measures of the local strength of the field, have enabled Jeremy to reconstruct the ebb and flow of the Earth's magnetism over the past 3 centuries. And it's what this reveals about one region in particular that's significant.
We've seen very abrupt changes in the Earth's magnetic field beneath the South Atlantic Ocean.
Beneath the South Atlantic, Jeremy has found clear evidence for a region of magnetic anomalies, places where the field has already started to reverse. And these anomalies are growing.
As we get into the beginning of the 20th century, we see the emergence of a new patch of reverse flux, a region where the field lines, instead of coming out of the core, are looping back into the core. And that patch then drifts towards the west, hooking up with this other patch of reverse flux to create a large region, what we call the South Atlantic anomaly, where the field is about 30% weaker. And that patch has grown substantially during the last 100 years in particular. So one question we're all asking ourselves at the moment is the Earth's magnetic field about to flip?
In a region of the core 2,000 miles beneath the South Atlantic, the magnetic currents have reversed direction, canceling out the main field, causing its strength to decline. If things continue like this, then we could experience a magnetic phenomenon the Earth has not seen for 780,000 years. A complete flip of the entire global field.
There's really no question about whether the Earth's magnetic field will reverse again. The question is not if that's going to happen, it's when that's going to happen.
Actually, in the last few hundred years, the intensity of the magnetic field on the Earth has been decreasing, which is an indication that maybe we're in for a reversal.
日華牧師就此作出分析，呢一種南北極出現嘅反常現象， 正好係 Webbot 所曾經預測地球將會出現多個南極同埋多個北極嘅現象。呢個正係地軸轉移嘅先兆。當地軸轉移出現嘅話，就會帶嚟全球性海岸線事件。因為地球嘅自轉突然轉向，會令海水衝上地面。亦都因為地球自轉嘅速度高達每小時1670公里，如果地球自轉突然相反轉動嘅話，就會將地球嘅海水全部都衝上地面。其實歷史上好多歷史文獻都記載咗地軸轉移，而且係呢啲古老文明嘅人親身嘅經歷。可見，首先發現地軸轉移嘅並唔係呢啲科學家，所以地軸轉移唔可能喺幾十萬年前發生。實際上係因為 Planet X 每幾千年一次逼近地球而引發，亦證明呢啲科學家用所謂碳14嘅方式去驗證物件嘅年份係錯得離譜嘅方法，因為誤差係可以相差幾百倍甚至幾千倍。